I'm on 348. So a hypothesis test is a process that uses your sample statistics that you just found to test a claim about the value of a population parameter. A claim is made about a population parameter. A parameter can be the mean, can be the standard deviation, can be the variance, can be a proportion. These are your parameters. Remember when we looked at your mean versus your sample mean, your standard deviation versus your sample standard deviation, your variance versus your sample, your p versus your p hat. This is your population, this is your sample. So we're still testing a claim about a population. When we get rolling on this, the first thing 7.2 does is do the mean. Then it does a proportion. Then it does a variance. Kind of like your confidence intervals do. But in this one, we kind of have to learn the overall part of hypothesis testing. So, for instance, consider that a manufacturer advertises that its new hybrid car has a mean gas mileage of 50 miles per gallon. You suspect, since you bought this car, you don't think it's 50 miles per gallon. How could you show that this advertisement is false? Okay. You can't test all the hybrid cars in the population, right? So you therefore find a sample. You take a random sample from your population using all the random sample methods that we've learned before, and you measure the mile of each to get a reasonable decision about your population. You take your sample mean, and you're going to test it to see how far off it is from the population mean. And from there, you can decide if this advertisement is false or not. We still never say it's true or it's false, or it's incorrect or it's correct. We'll use the words reject and support, depending on which person is doing this. To test the population gas mileage, for instance, hang in there guys, you need to understand this. You take a random sample of n equals 30 and you find that the sample mean, here's your sample mean, is 47 miles per gallon with a sample standard deviation of 5.5 miles per gallon. Usually they will give you a population one. This is usually going to be a population standard deviation. Does this mean that the advertisement is false? Just because it's not exactly 50, does it mean that it's false? You're going to have to remember that your standard deviation factors into this. You're going to have to remember that your standard deviation, like the plus or minus 1, is where most of your data falls. The plus or minus 2 is unusual. The plus or minus 3 is very unusual. So it has an opposite effect. Where we would say that your confidence interval was 95%, we're going to test this guy off of an error of 5%. It's got the opposite effect on this. Okay? So you're going to test your sample against your population, and you're going to make a conclusion. You can conclude that the advertisement is false, or that you have a bad sample, and that the advertisement is not false. Now, the problem with the sampling is we can't conclude that your samples are false unless they tell us it is, because we're not doing the sampling. But in real life, what happens is, say you do a sample of 30 and you decide it's too far off, like it's just too far off of my population mean. Let me do another sample. Let me test another sample. And before you make somebody's claim and say, that's wrong, they claimed the wrong thing, you're going to test, obviously, more than one sample. You don't want to be the one that tries to prove them false, and actually you're the one that did the wrong research. So this is a very big process to go through for this, and we're just going to be touching the tip of the iceberg with this. So your sample standard deviation will show how far off you are from the mean. Here's your mean. This came out to be about 1. So if you just look up here a second, if here's your mean in here, and your sample standard deviation came out to be about 1, look how far away it is from the mean. It's 3 standard deviations away from the mean. That's pretty unusual, right, Nick? Very unusual. 3 is very unusual. So it may be that you could say this is false, or you could say, let me check my sample again. Let me make sure that I have the correct information. Okay. Now, if you need to have a conversation, you guys are going to need to take it somewhere else. Okay. Stating a hypothesis. This is the most important part about your research, your experiment, your scientific experiment, and your statistical experiment. It's your hypothesis. It's what I am looking at. How am I going to test this? And in statistics, it's going to make a big difference because one is going to be your built hypothesis, and the other one's going to be an alternative hypothesis. So it makes a big difference on how we state this. A verbal statement or a claim is what your hypothesis is. To test this, you're going to actually make a pair, and I put this in your note page, so you might want to be going along your note page with me. You're going to test a pair of hypotheses. One is going to be a null, and the other one's going to be an alternative. It's going to be the opposite of your null statement. Okay? If one of these is true, then the other one can't be true. It has to be false, because they're opposites of each other. The null hypothesis or the alternative hypothesis may be the claim. One of them is the claim, the other is not, and it doesn't matter to us. The null hypothesis, this is the most important part, is the one that contains the statement of equality. It has an equal sign in it. If I say greater than or equal to, less than or equal to, or just say equal to, at least, that's got an equal in it. At most, that has an equal in it. My null hypothesis always contains the equal sign. Therefore, the alternative hypothesis does not contain an equal sign. If this one says greater than or equal to, this is your null, then your alternative has to be the complete opposite of that. What is the opposite of greater than? Less than. And we can't put less than or equal to because the alternative one does not have the equal sign in it. So these are complete opposite pairs of hypotheses. Therefore, if one is true, if it's greater than or equal to, it cannot be less than. If it is less than, then it cannot be greater than or equal to. So one of those pairs is what we're looking to prove true or false. The alternative hypothesis does not contain the equal sign. And if you put a little note, this is where your sketch comes in. This is where we find the tail that we shade in. This is what we're eventually going to be finding. I know this isn't the most exciting and you probably can't figure out where this is going. Just stay with this. Okay. So, to translate the claim about a population parameter from a verbal to a mathematical statement, we translate it using the greater than, the less than, the equal to sign, and then we find its complement, the exact opposite of that. Our claim could be the alternate one. It could be the null one. We have to look at those. I put a little chart in here that these will help you kind of like figure out where you're going with this. If the HO says greater than or equal to, at least, not less than, these are all greater than or equal to. So therefore, the HA has to just say less than. If on the opposite side, we say less than or equal to, at most, less than or equal to, not more than, less than or equal to, then your alternative has to say greater than. It's exactly the opposite. If your statement says equal to, exactly, or just listed as this, is this, usually they say is, this is your hypothesis statement, your no statement. Your alternative, notice, has a not equal to. That's completely the opposite of equal to. Good? This is really, really important. Alright, so let's try this. A school publicizes that the proportion of its students, these are all populations. So first we're going to say proportion is a P. This is population when they talk about this. A school publicizes that the proportion of the students who are involved in at least one extracurricular activity is 61%. So how do I write this statement? How do I say at least? So the equal then sign goes with the no. HO is no. HA is alternative. No, what's the opposite of greater than or equal to? Look at your chart. Less than 61. Now, I also want to throw in a little sketch right now. The sketch follows the one without the equal sign. So draw me a left-handed, well, if you're writing this down, you would want a left-handed test. We're gonna be including that in it in another little bit, probably tomorrow. But for now, we're gonna remember that the tail follows the guy that is not equal. Very good with that so far?
Wait, it follows the one that's not equal.
It follows the one that's not equal. Now, good point. This is the claim. This is the statement that we wrote. Everybody, if you're writing this down, and this is a good thing to do, write down the claim. The claim is the statement that is made right there. The statement could be either the HO or the HA. Okay? Now, let's try another one. A car dealership announces that the mean, here's my mu, the mean time for an oil change is less than 15 minutes. This is a claim. He announces, he claims. How do I write this statement? The mean is less than 15 minutes. I just need to write that statement. 15 minutes. Would that be the HO or the HA? HA, because it doesn't have an equal sign. There you go. Now, do you see this one is the claim this time? It does not matter which one is the claim. So, therefore, your tail is also going to be a left tail. It's going to follow that guy. What's the opposite of less than? Greater than or equal to, because this guy's going to have the equal then sign. Yes. Well, it can be greater than, but you didn't include who's equal to it. And the HO always has the equal number in it. The HA does not. So if this one does not, you need one that does have it. If this one does have it, then you need one that does not have it.
How are the sketches?
The sketch is not the same. It always follows the alternative.
But why are those two the same?
Because these are both the less than.
Oh.
Yeah.
I thought it goes by the claim.
Nope. It goes by the sketch goes by the HA.
Oh.
The claim, notice in this one, the claim is either one, right? The equal sign is always the HO. In this case, yes. This was the HA given to you. So it shows us that the claim could be either one, the no or the alternative. Could be either one. The sketch always goes by your HA. Always has the one that doesn't have the equal sign. I know this is a lot to get, And your heads are spinning saying, what is she talking about? But stay with me.
First cousin out, and why are you using 1/6 not 1? Anything less than that.
It's a proportion. Proportion is P, proportion percent. So we converted it to a decimal. Okay, let's try this one. A company advertises the mean life, there's your mu, of its furnace is more than 18 years. HA, more than 18 years. This is the claim. This is what you're looking at. More than. Start like this. Don't even put it in HO and HA yet. Mean is more than 18. Then we say, well, if it's no equal sign, it's the HA. So this, my claim, is here. My tail follows a right tail. It follows where your HA points. How do I write my HO? Less than or equal to 18. Good. The HO has to have the equal sign. The HA has no equal sign, but it follows the sketch. The claim, notice, the claim can be either one. The mean is a mu.
No, I always thought the symbol was like a U. It really is like an M, like a fucking
It's a little scripted U. It's like a script U. It's called a mu in Greek. It's Greek letter mu. Probably me. It's like this. It's a U. Yeah. Okay. I want you guys to try these. So hopefully you wrote something down or you actually listened to me or went along with me.